Hey guys, so we're thinking about volume here. So different than finding area and perimeter, which is where you find sort of the space inside or the space it takes to go around a two-dimensional shape. Volume is that, but for a shape with three dimensions. So it has not just a length and a height or a width like we have in a two-dimensional shape, but we add in that third dimension of depth, or what we might here be calling width. So we have a length, we have a width, and whoop, we go up, we have a height. Three dimensions. So, volume, we can say, is the measure of that space inside of a three-dimensional figure, right? So, how many of these little blocks it would take to fill up this shape, this three-dimensional rectangular prism. So we might say we have one sort of row here or layer of 3, 6, 9, 12 blocks. And we have how many of those layers? Well, we have 2, 3, 4 of those layers. So we could then measure, so it's measured in cubic units, which is what we're talking about there, those little cubes, right? This little cube here, how many of those would it take to fill the space? How many layers of the blocks are there? So in writing it, you can calculate the volume of a rectangular prism. This is a rectangular prism because the base of it is in the shape of a rectangle, right? With two sides sort of being the same length, opposing sides on both of the sides with all parallel sets, right? Of opposing sides. So you can calculate the volume of a rectangular prism by counting the number of cubic units, right? Doing just what we did there of counting those little blocks. So you could count up those blocks. You may also, if you don't know, if you don't have the physical blocks to count, or you don't have the lines drawn in like we do here, right, to know that this is a cube, a little cube, you can also calculate the volume of a rectangular prism using a formula. So the formula is found by multiplying all of your sides together. And you can see that that works because that's essentially what you're doing when you are counting up those cubic units, right? You're saying, if I know that this whole layer is 4 high by 3 wide, and then I have 4 of those, right? We did 12, 3 times 4, which is 12, 4 times, or 12 times 4, right? That is what we do in the formula. It's just a faster sort of way of counting up those units, just like multiplication is a faster way of doing repeated addition, right? So the formula is simply length times your width times your height, right? So you could say I see that there are 4 units in my height and 3 units in my length and 4 units in my width here. Or sometimes you won't be able to count them up. It'll just be given to you. So you might be seeing that the height is 4 without having the helpful sort of tool of having these drawn on for you. Okay. So when you do it here, you're going to be counting up. So go ahead and see if you can find the volume here. You can pause the video and try it on your own. Great. So here we go. So we can count and see that we know, let me get the pen, that this is 1, 2 units high, right? It is 3 units wide, and it is, let's see, 3 units sort of long here. So we have a 3 by 3 by 2 unit rectangular prism. So we can say 3 times 3 is 9, times 2 is 18 units cubed because it's three-dimensional. So our units become cubed. You can see that little tiny 3 up there implying